Hello everyone. Let's start this recorded video lecture. And we were discussing relative motion and related to that relative motion and as other parts of kinematics. We will have some problems and we will solve them one by one. And what you can do, you can follow the old strategy, like you read this question, pause, solve, and then check. So let us start. So this question reads, two particles 1 and 2 move with constant velocity v1, v2. These are the velocity vectors. And initial moments, their radius vector or position vectors are given r1 and r2. It says how must these four be interrelated vectors so that the particles do collide. So how we can solve? Solution can be like this. We would like to use this relative motion. So what you can do, you can think of that is this is your coordinate system. So let me draw coordinate system x and y. And in this coordinate system, the two particles are located. It could be three-dimensional or any dimensional. I'm just able to show two-dimensional in this case. And let's say this is the particle 1 located initially. This is the particle 2 located initially. And then you can join their location from the origin. So that will become position vector of 1. This will become position vector of 2 with following direction. Direction goes from origin towards the location. So that's the position vector. And this is R1 vector. And this is R2 vector that is given to us. Now it says that they are moving. So let's say v1, this will have a velocity v1. In what direction this v1 is, we don't know, right? So I'm just writing it as its velocity is v1. I'm not showing the direction. And this is velocity v2. And we need to find what the relation they four must carry, or how they must interrelated so that they collide. That means this particle goes to this or this particle goes to this, and they meet at the same time at the same position. So collision means the two particles are located at the same location and at the same time. So that's called collision. Anyway, so we will be using relative motion. So using relative motion, we will say with respect to, let's say we are drawing the situation with respect to particle number 1. So 1 will appear itself, wherever this 1 is going to appear itself as a rest. And as per this 1, we would like to know what the position of 2 is. So now our new origin will be acting as a this. So this will no more be as a origin. This was origin for this coordinate system. Now origin will be here, this reference location, and this position vector we need to read. So we are going to read the position vector of this 2 with respect to 1. So we'll say position vector of 2 with respect to 1. That's what we want. And we know, we have already understood that this is written as position vector of 2 minus position vector of 1. And by the way, R2 and R1 is known to us. So we got to know this. This is a position vector of 2 with respect to 1. So we are watching everything with respect to 1. Now if they have to collide, so 2 must be coming towards 1. So let's talk about the velocity. So we will say velocity of 2, if we write velocity of 2 with respect to 1, is going to be velocity of 2 minus velocity of 1. So we are using the vectors, so proper way we are writing them. Now if we see everything with respect to 1, so how it looks like? It should look like this. This is 1 and that's origin, and this is a particle 2. So you can think of that as the observer, and that observer is watching this two particle. And what we have understood, or we know by this drawing, that we know this position, that means where this particle is located. Moreover, we got to know what the velocity of the particle 2 is. So this position is r2, 1. So that's position. And we also know what the velocity is. So velocity is written as v2, 1. Right. Now, if 2 wants to meet with 1, because if the collision has to take place, so 2 must be moving towards 1. Then this velocity must be directed in this direction. If velocity is in this direction, that means opposite to this, so that it can hit this. So the direction of velocity must be opposite to the direction of position as per 1 in order to this 2 meets 1. Making sense? And we know the vector, so we can say for collision condition becomes for collision condition is that the two vectors must be opposite in direction, which means direction of r2 vector with respect to 1, that's a direction, must be negative of direction of velocity vector with respect to 1 and whatever is written, right? So this is what we can do. And then we know the vector, and we can use the rules that direction is written as a vector divided by its magnitude, so it will be written as r2 vector minus r1 vector divided by its magnitude, that is mod of r2 vector minus r1 vector, must be equal to negative of v2 vector minus v1 vector divided by mod of v2 vector minus v1 vector. So this is how four must be interrelated in order to claim the collision. And if this situation is not true, then they will never collide, right? So this is how we can use the vectors to find the condition for collision. So here is the next problem. It says 3 points are located at the vertices of an equilateral triangle whose side is given as A. They starts moving simultaneously and with the speed which is same for all, v, and the first point heads towards second point continuously, second is towards third point, and the third is focusing the first, and it says how soon they will meet and where. So here we are dealing 3-point motion. So it's like we have started with for first particle, then we are talking about the 2 particles, then we are talking about the 3 particles, and we can go for the number of particles motion simultaneously. Anyway, so let's proceed for solution. Solution can be of this sort. So first we need to go for an equilateral triangle. So let's say this is an equilateral triangle, and there are 3 particles located at the vertices. So let's locate all the 3 particles. Let's say this is particle number 1 initially or at any instant. This is particle number 2. This is particle number 3. So this picture is, let's say, of initially. So initially this side of this triangle is going to be A. That means separation between these particles is going to be A. And how they are moving towards next. So this is moving for targeting the second particle. This is targeting the third particle. And the third particle is focusing towards first particle, right? So this is how it explains. So this is the initial situation at t equal to 0. Let me explain the question, what happens later on, that means as t passes, and whether they are going to meet at all. So what's going to be the case when the time passes? So let's think about that this one has moved a bit, a very small distance, but that distance I'm showing by a larger one. So I'm showing by this, but not exactly, it's very small, like let's say just ahead of it. To show it clearly, I'm taking the point here, and let's say in that time the time has gone just beyond the 0. So we say time is tending to 0 plus. When we say 0 plus, that means just ahead of 0. So at that situation you'll find this 2 will be slightly moving. So let's say that slide is shown by large number here, so 2 might be reaching there, and then 3 again moving slightly forward. So let's say that's the next position. So we can say these are the next positions. And if you draw next velocity vector, so you'll find it will be some sort of this. If I draw another, so you need to join this 1 with this 2, then you need to join this 3 with the 2, then you need to join this 1 with this 3. You'll find this kind of again equilateral triangle will be formed. And now this 1 will be targeting 2, that means direction is changing. This will be targeting 3, this will be targeting 1. So idea is that velocity is variable and velocity is towards the next particle. Can you think of what happens next? In next moment you'll find this will be moving somewhere there, this will be moving somewhere here, and you'll find this kind of equilateral triangle can be constructed. And if you go further ahead, and in this particular situation you'll find velocities will have directions this. So they will be having velocity always towards the next particle. That's a condition this question says. And however, as far as the magnitude is concerned, magnitude remains v. So thus speed remains the same. However, direction changes, hence velocity changes. Now you can see they are coming closer. Now the distance between 1 and 3 is reduced. Earlier was a, and this will keep on happening, and ultimately they will join each other at the centroid of the triangle. So it's asking where they are going to meet. So you say at the centroid, because it is symmetrical and it's equilateral triangle, everything is symmetrical, so they will be meeting at the centroid point, and they will form every moment an equilateral triangle, and that triangle keep on reducing in dimensions and vanishing at the center or centroid. Making sense? So this is how the particles are going to move. This is a very complicated problem, isn't it? And if somebody says find the path of one or trajectory followed by one, so can you think of how the trajectory of one is going? It's going like this, then bending, then further bending. Might be so many triangles, then coming like this, spiraling, and ultimately going to this. So you'll find the path of any of the particles are going to be a complicated path, which is very difficult to find the equation of, and very difficult to find the distance covered by any particle. However, some of the questions we can answer, like how soon they will be meeting, and this we have already answered, where they are going to meet because of symmetry. They are going to meet at centroid. How soon they are going to meet, we can solve that by using relative motion concept. So let's start with this situation. Let's say considering 1 and 2 particles only. Now when they are going to meet, we will find that all the 3 will be meeting simultaneously, right? That means if we can find when 1 and 2 are meeting, so that will become the answer when all of them meeting, because all of them are going to meet simultaneously. So you catch any of the 2 particles. Let's say we are thinking how they are, when they are going to meet, or you can cover 2, 3 or 3, 1 or any of 2 out of 3. Now let's say start with this initial velocities that I have drawn. So I'm redrawing, just redrawing the same picture. So that's a v. And this will have a velocity in this direction, and we know this direction, this has to be straight line, so roughly straight line I'm drawing anyway. And you will find this is going to be an angle 60 degree because of equilateral triangle. Make sense? Now this velocity, whatever the velocity we have drawn, this is at an angle 60 degrees, so this can have 2 components. One component will be in vertical direction, another component will be in horizontal direction. And what these values are going to be, very easy to identify. If this was v, so let me write this v where it was. So this should have been written here. So that's a v. And this will be component of it, so that's going to be v sine 60. V sine 60 is going to be basically root 3v by 2. That's a perpendicular velocity, and this horizontal component of velocity initially come out to be v cos 60, and cos 60 is half, so that becomes basically v by 2. Now here we need to use some concepts of physics, like the 2 particle has to meet. So that means this separation, which was a initially, this separation has to be reduced. So this is a separation, it has to be reduced to 0. And this is a distance, so we want this distance to be reduced to 0. And we have understood, like this velocity distance can be covered by those component of velocity which is along this direction. The perpendicular component of velocity will play no role in the reduction of this length, right? So these 2 velocities will be playing a role to reduce this. And since these 2 particles are having velocity in such a way, they are coming closer, so this distance has to be reduced. Now, if you look at the entire picture, so the separation between 1 and 2 will not remain horizontal always. As you see, later it becomes this, then it becomes this, then further it will be changing in direction. However, at every moment this angle will remain 60, so angle will not change. At every moment this speed remain v, this is speed remain v, so v is also not changing. So we can find the relative velocity with which they are approaching. So that's also called approaching velocity, or velocity of approach. So we can write velocity of approach. That means the 2 particles are approaching each other with what velocity? and that velocity of approach is basically velocity of, you can say, 2 with respect to 1 in the direction of that length along separation direction, along line joining the two particles, So whenever we talk about the velocity of approach or velocity of separation, there's always velocity of one particle with respect to another along the line that joins the two particles. So we just forward this thing and we are thinking about only these two components of velocity, right? Can we find what this velocity component is going to be using the relative motion? So velocity of 2 with respect to 1 in the direction of line joining this direction. So you say this is a velocity of 2 and this is a 1, so give it in reverse. So when you give it reverse, let me draw here. So we are talking about this 1 particle and this was a 2 particle, and this has already a velocity called v by 2. And its one velocity has to be reversed. So that becomes in leftward direction. So, and it also coming to this, so it becomes v. So total velocity is this. So velocity of approach is going to be v plus v by 2, which basically says it's a 3v by 2. That means, or we can say speed as well. If we are not interested in direction, saying this direction, so speed along this length. So we can say its velocity along the line of joining, that's the velocity of approach, basically is going to be 3v by 2. That means for 1, it will appear that 2 is continuously approaching it with a speed or velocity called 3v by 2. And how much it has to be traveled before it meets? It has to travel a distance. So we can say it's time taken, how soon, that means time. So time taken is going to be how long it has, how much it has to cover, that is a, with which velocity, the velocity of approach. So I'm writing VAPP, that's approach velocity. So distance upon approach velocity is our answer, and the distance is a. Approach velocity we just have calculated, which came out to be 3v by 2. So final answer will become twice a upon 3v. Makes sense? So this is separation. So this becomes your answer. Let me quickly say what I have done. Lot more thing. Question was like particles are approaching each other but in a different manner. So you just consider any of the two and find out the components and see those component of velocity which is along the line joining the two. And whenever we need to find the velocity of the approach, always write this velocity along the line joining, since it is a relative. So 2 with respect to 1 or 1 with respect to 2, any of the two you will find. You will find this magnitude. Once you get the speed, divide it this with using this distance, you will find the time when they are going to meet together. So there is the next problem, and it says a ship is sailing at this kilometer per hour. So here's the correction. This is 20 root 2. So root 2 is missing. So it's a 20 root 2 kilometer per hour in the northeast direction. Okay, so that's a northeast direction. And certain instant B ship is 50 kilometer due south. So I'm drawing this as a 50 kilometer due south. So that's a B. B is sailing at a speed this 40 kilometer per hour in 30 degree east of north. So we can draw that velocity as well in this picture. And this is in this direction. And this velocity is 40 kilometer per hour, and this angle is 30. It's a 30 degree east of north. So from north towards east it is 30, and it's the shortest distance between the ship. We need to find what the shortest distance is. So whenever we need to find shortest distance, the relative motion is helpful. And we also need to find when this shortest distance will be achieved, that means time. And we need to then claim whether they are going to collide or not. So let's try to solve it. So I have drawn a picture, so you see that picture. And in this picture, this angle is 45, because when it says northeast, that means in between. So that's a 45 degree. So what we do, we simply make the components the way we know. We can make this component of velocity, another component of velocity of A is going to be this. This is 45, so this becomes 20 kilometer per hour. This is also going to be 20 kilometer per hour. Similarly, we can make the component of this velocity of b, one in the eastward direction, another in the northward direction. Eastward is going to be 40 sine 30. Sine 30 is half, so that becomes 20. And this vertical component is going to be 40 cos 30 degree. And the 30 degree is root 3 by 2, so 20 root 3. So that's what it becomes, right? Now, again, how to solve it? You take the frame of reference of any of them. So let's say with respect to A, that means in A frame of reference we are working. So A will appear momentarily at rest. So A will not be moving as per A reference. B is south of this, so that's a B. And we need to find the velocity of this B as seen by A. So velocity of B, whatever it was, that will be there. So velocity of B, that was these two components. One component was this, which is 20 root 3 kilometer per hour. Units are same, and this is 20 kilometer per hour. So these were the velocity of B. Now use the velocity of A and reverse and add with this. So this will be reversed in this direction, so that will become 20 extra coming in, and this will be reversed, so that will be downwards. So that's a 20 extra coming in. So this will be the velocities component of B as seen by A. Now we can sort it out how much the velocities are coming. So you will find the velocity of B in totality, they are getting cancelled out, will be in this direction, and that is coming as 20 root 3 minus 20 kilometer per hour. So that becomes the velocity of B as seen by A. And how much you see this velocity is along this direction, so they must be colliding, right? So from here it decided that the collision must take place. So that means, will they collide? You say yes, they will collide. And after how much time they will collide, we will find. And how shortest distance will be 0 when they are colliding, so shortest distance is 0. And the time after which they will collide, the separation between AB, that is given as a 50 kilometers. So you write it as a 50 kilometer divided by the speed they are moving with. So it's going to be 20 in bracket root 3 minus 1. These many hours it will take to collide, right? You can simplify this further, or you can leave your answer in this way depending on the options. So let's read this question. It says the ball is hit by a batsman at 37 degree as shown in the figure. So you can see this figure, and there is a man standing at a P point. So some person is standing here. It says what minimum velocity that person should run to catch the ball before it strikes the ground. We need to assume that this person is of negligible height as compared to the maximum height, so that we can consider it as a point location. Okay, so how we can solve it? So there can be n number of ways to try it. So let me tell you one way. First of all, you can make the component of this velocity. So this velocity will have one component horizontally, another component vertically. This is going to be u cos theta. You know that u is 15, cos theta, cos 37 is going to be 4 by 5, which leads to 12. This is going to 3, and that's 12, right? And if you talk about this, so it's going to be sine 37, which is going to be 3 by 5. So it's going to be 9 meter per second. So these are the velocities, right? So this is ux, that is uy. Or you can also write in terms of sine theta, cos theta. That's also okay. And first of all, we need to find where it's going to land. That's the range. So we can find a range. If we are interested in finding a range, total is going to be twice times vertical velocity, horizontal velocity divided by g. That's a formula. So 2 is 2, vertical velocity is 9, and horizontal velocity is 12, and this is divided by g, which is 10. So this is a number we can find it out how much that's going to be. So you will be solving, then you'll find it's going to be 21.6 meter. So that is going to be range. So A to B is clear. Now we need to find that this man can catch this ball. So we can use the relative motion over here. So let's say with respect to man, or with respect to this person. That means we are taking the frame of reference of this person. So what will appear for this person? Let's say this is the person. Now this new situation is here, and we are throwing this ball from this point A. So we need to know what this distance is. Can we find this distance? Yes, we can easily find. This distance is going to be whatever the total we are getting, 21.6 minus 9, because this is a 9 meters. So this is going to be the total one. You can subtract this, so it's going to be a 0.6, and if 9 goes over here, so it's going to be 12.6 meter. Right, so what will appear for this person, that I was stationary and a ball was shot from here in such a way, if this person catches the ball, so this ball must reach to this. That means this must become the new range. Now if you want to make this as a new range, so what the velocities of this projectile is going to be, the vertical component of velocity will not change because the person is not moving in the vertical direction, so this will remain uy, the same uy, which is 9. However, this ux will change. So let's say this person in actuality is moving in this direction with velocity v0, that's what we are looking for. So with respect to this man, this velocity will be given in reverse. So this projectile will have one component of velocity which was earlier 12, and this will be given in this direction v0. And still this has to come to this person, right? That means total velocity has to come in this direction, forward direction. So the total velocity in the x direction, that we can call as, let's say, ux dash. That's a new one. It's going to be equal to 12 minus 9, this v0. That's the v0 we need to find. And this uy will remain the same as it was. So the velocity in the direction of x will change. Now we can write the new range. New range required is how much? That we have already calculated. New range required is 12.6. And we can apply the formula of range again. So we will find it as 12.6 is equal to 2 times uy, that's the velocity in the vertical direction, initially, into ux dash, that is new coming in, divided by g. That's the formula. Now you can put the values. 2 remains 2, and the vertical component of velocity was 9, so it is still 9. Okay, let me write downside space constraint. So that's going to be 2, that's going to be 9, and that's going to be 12 minus v0, 12 minus v0 divided by g, which is 10, and this is 12.6. Can you see this one? This is one equation in which v0 is the only unknown. After solving this, you can find what the v0 is going to be. So if you solve this, you will get your v0 value correctly. Whatever this value is going to be, that's going to be minimum as well, because it's asking about minimum. So why this is minimum? Because this person has to run at least with this velocity. If it is moving faster than this, it's okay. The person will reach earlier over here and easily catch this thing. And if the person is moving with less than this velocity, then that won't work, because the ball will fall before the person reaches, right? So that's why this is going to be minimum. Okay, so that's your answer. So here is the next problem, and let's read it. It says an object is released from a plane flying horizontally with a constant velocity at a height of the surface. There are two observers, observer A, who is on the plane, and the observer B, who is on the ground, and we need to find the path of the object as observed by these two observers. So let's solve over here. For that sake, we can draw first of all that this is the ground, and on this ground there's a person, and there's a plane flying over here. So some plane might be flying like this. Okay, design is not so important, but yes, this is moving with velocity given, which is a constant velocity, and an object is being dropped from here. So a person is inside it, so there's a person A, and an object is being released at any moment, and there's another person B on the ground. So we need to see what type of path this object will follow for A as well as for B. So there's one point that I want to make you clear, and that is very important as well. What happens when you detach any object from any platform, like this is a plane, or maybe train, or maybe balloon, or maybe anything. So whenever you detach any object or release from that thing, so what happens like this? This object will acquire as per the ground. This object will carry the same velocity as this platform was having at that instant of time when it was detaching. So if you look from the ground, you will find it will be having the velocity equal to the one which the plane has. Moreover, if this plane had this acceleration a, then this object will not carry the acceleration, but it will carry only the velocity of that moment. The reason being, this acceleration comes because of the force acting, right? So if this, in the particular case, this is not having any acceleration. Suppose if it had acceleration, so this object will not carry that acceleration. That's the point I'm trying to say. And why this object will not carry that acceleration? Point is simple. When you release this object, now what are the forces acting on this object that will decide what the acceleration is? So basically acceleration comes because of the force. Okay, so force decides what the acceleration is. When your plane moves with acceleration, that means engines are creating some force by pushing the air, right? And once this is detached, that means now engine's effort is not on the object, and this object cannot create a force by itself, right? So this object cannot have the acceleration. So this acceleration is coming because of force. That's point you need to remember. So what the nutshell point is, any object, if it is detaching from any platform, it will carry the same velocity with respect to ground as that object carried at that moment with respect to ground. And the object will not carry the acceleration whatever that platform carried. Anyway, in this particular equation, it says constant velocity, so acceleration was 0, so that will keep on moving. That means this plane will keep on moving with the same velocity v. However, this object will be having detached like this with respect to ground. So first we are talking about with respect to ground, with respect to B observer, that's a ground. So with respect to ground, it will appear like this. There is an object. This object has been given a velocity v, and the ground is downside. So since ground is downside, then you'll find it will be following a path that we know. What type of path? It will not come vertically downside, of course, and neither it will go horizontally forever, of course. So it will be falling like this. This is going to be projectile. So that will be parabolic path. So we will say path is going to be parabola. Who has observed this? The observer on the ground. That means the observer B. So as per this, it's going to be parabola. Now the point is, what the observer A is going to witness or experience or find out the path of this. Now when this observer, if you ask from this observer A, that will not be able to notice this velocity, hence he or she will not be able to notice this velocity. So for that observer, it will appear that this object has been dropped, right? So for observer A, it will appear like this. This is the object and it has been dropped. That means it carries no velocity. Since it carries no velocity, so its path is obvious. What is the path? It will fall down vertically. It will fall down vertically. That means observer A will experience the ball is moving on a straight line. So answer is going to be straight line. So the two observers will find the same object moving in different paths, and that is because of relative motion. And if you want to understand this much better, then you can think of, go further with respect to ground. So this is V with respect to ground. And we know if we take any frame of reference, we give this velocity in reverse. So we give this velocity in reverse. So for observer A, this will be the total velocity. That means no horizontal velocity. Hence, it's going to go down on a straight line. Making sense? Similar question was asked in JEIIT exam a couple of years back. They asked like when this ball is dropped as per this A. So they asked when this ball is being dropped. So simple question could have been asked whether this ball is going to fall at this point or this point. So you say it won't fall here on the ground because this is on the ground. So on the ground it's not going to fall vertically down. It will be following some sort of this. But this path will appear this observer as a straight line. Anyway, so the question was this, that let's say this object lands at this point. When it is landing at this point, and let's say this point is C point. So what is the position of this plane. That's what they ask, whether this plane is going to be just vertically upwards. So they draw like this. Let's say this is one position of the plane, and another position is ahead, and another option is behind. So there are 4 options. The question says when this object lands on the ground at any point, at that instant of time where this plane is flying, is it just above this point where it hits the ground, or ahead of it, that's point 2 or position 2, or below behind that location, that is 3. So this was the question that has been asked. Can you answer which option is going to be the case when the object falls and hits the ground? So you can see both are moving with the same velocity, and you already know that this velocity will not change because of constant velocity motion, and this in projectile motion, horizontal component of velocity also does not change, right? So they will have a same displacement in the horizontal direction in the same time. So this is the horizontal displacement of ball. So this must be the horizontal displacement of plane. That means it must be just above. That means option 1 becomes correct option, right? Then we can have another variations, like if it is if let's say this plane was accelerating instead of having constant velocity. So in case of acceleration, you'll find now this velocity will increase up and this will remain constant. Hence, second position will become your answer, because the plane will go ahead because of a higher horizontal velocity. And if somebody says it is deaccelerating, then you can think of this velocity will reduce, this will remain constant. So third will become your answer. So first is answer for uniform, second for acceleration, third for deacceleration. Okay. Well, so let's consider this narration. It says a balloon starts from ground, accelerates upward with 2 meters per second square. And it starts, so let's say it starts from rest. So it's starting from rest, that's what it is trying to say. And after 10 seconds, the ball is being dropped, or a ball is being dropped from it. So when we drop it, we are going to use that concept over here. We need to find the time after which will the ball hit the ground and the distance covered during this journey or this time. So the solution can be as follows, and you can make this picture. So let's start constructing this picture at t equal to 0. This balloon starts from here with 0 velocity. Acceleration is upward, and that is a. So whenever we say this a is 2 meters per second square, it includes everything, and that's a final acceleration. That means we should not go for applying gravity with this, right? So this is after including the gravity as well, right? Later on, let's say this reaches here and it is still moving upward, and let's say this time is the time when it is being dropped. So that time is let me draw this here. That time is t equal to 10 seconds. So this picture is of t equal to 10 seconds. So at 10 seconds, what the velocity it will get, we need to find that velocity. Let's say this velocity is v0. So this velocity is v0. We can find this velocity of v0 if considering the motion of balloon. And how much that is going to be, you can think of it's moving with a constant velocity, right? So we can use the first equation. v0 is equal to u plus a. U is 0, a is 2, t is 10. So we'll get this velocity of the balloon at the moment this ball is being dropped is 20 meters per second. And it will have acceleration 2 meters per second square, which is because it is a constant acceleration is moving with, right? At this moment we are dropping an object. So let's say this object is being dropped. Some object or ball is being dropped. When you look at this ball with respect to balloon, then you'll find this ball will appear to go downside slowly. But we need to talk about with respect to ground. So let's see with respect to ground how it looks like. So with respect to ground, it will have a velocity in upward direction, and the moment it detaches, it will have the same velocity as that of the balloon, but it will not have acceleration that of the balloon, because we have just talked about that point, that when any object gets separated from a platform, it does not carry the acceleration, because this acceleration comes due to forces that is causing this acceleration, and these forces are acting only on the balloon, not on the ball, right? So this will have this v0 in upward direction, and it will be free in the air. Once it is free in the air, so gravitational acceleration will act downward direction. So this gravitational acceleration will decide the fate of this ball that will bring it downside. So that's the gravity. That means after this, after 10 seconds, this ball will having gravitational acceleration downside. So what the path it is going to follow, it will go to certain height and then return back and will hit the ground. So the ball is going to hit the ground later on. We need to find how much time it will take for this journey. So we can use that equation. So this was for balloon. Now we can use this for ball. So what happens for ball? For ball, we can think of this downside as a positive direction, and we can use all the equations. So for equation we will say how much displacement it has to cause downside. This will be equal to the same amount the balloon has gone upside, right? So we can find this h value. H value using the balloon equation is going to be ut plus half at square. So let me write over here, h is equal to ut plus half at square. This is the distance where the balloon is releasing this ball. Initially was 0, half a is 2, t was 10. So this came out to be 100 meter. So it's a 100 meter height. When we are measuring downside, so this ball has to get a displacement downside. So this has to be written as a positive. H can be written as 100 meter. And acceleration for this balloon, this acceleration is now downwards g, and this is, we are getting downwards as a positive. Then you can write this initial velocity of this ball. So that's upward v0. So it's going to be minus v0. Minus v0. Basically v0 we have already calculated, so it's going to be minus 20 meter per second, right? So this is what we have got. Using these equations, information, can we find the time? Yes, we can find the time. So h is equal to ut plus half at square. We can apply this. Now let me put the value of h, which is 100, and u, which is minus 20, and this is t, and this a is going to be as a plus, is going to be a half. In place of a, we will write g, which is 10 into t square. Can you think a has been replaced by g? G has been taken as a 10. So this is a quadratic equation. In t, you can simplify, solve. You will get two values of t. So I have written what the answer you are going to get. T value is going to be 6.89 second and minus 2.89 second. This will be scrapped because that's a negative, non-acceptable, and this is a positive because after 0 it has to be positive number. So it will take 6.89, or either way we can say it's going to be 6.89 second for it to come downside. And if we need to find the total time on the clock, started from 0, so add this 10, so you will get the total time on the clock, and the time of this motion is 6.89 seconds. Got it? So that's the time. And how much the distance it is covering? Can you find what the distance is going to be? So distance covered by the ball. Yes, we can find it out. This distance will include the height that it rises upward from this level and the downside one. So let's say this downside one is h and upside one is h1. So we will write it as twice h1 plus h. Why twice? Because going upside as well as coming downside. Why only h? Because it's coming downside during this time. That means after being dropped. Now what is this h1? Can we find this h1? Yes, we can find h1 has a formula. This is the initial velocity you can think of. So it's going to be v0 square upon 2g. v0 square upon 2g. You remember that formula if you throw at u, so it goes u square by 2g. And this h we have already calculated how much. That's 100 meter. So that's going to be 100 meter. Now we can simplify v0 square. v0 is 20, square becomes 400, and this two getting cancelled out, so that becomes 40 plus 100. So overall it gets 140 meters. So 140 meter is the total distance traveled. If it is asking what is the displacement, so this is the displacement, which is h, we have already talked about, and displacement is downside. Fine. So this is how we can solve this point. So from here, the critical point that has to be catched: when this detaches, velocity as per the ground, you will find the same velocity as that of the platform, but not the same acceleration. Acceleration will be decided where this object is, in what condition it is. It is in air, so this is gravity that's going to act as acceleration. Okay, so that's all for this video. In this video we have covered a couple of questions and they are helpful for you. Thank you for watching. Have a great time.